So let's discuss the properties of matter, because all matter can actually be defined by some of its properties. One of the first is the physical properties. So physical properties are properties that can be observed without changing the substance. So observed, we can just look at it. These include things such as color, density, conductivity. So conductivity is conducting electricity. Just these physical properties of the substance. And if we're not talking about the physical properties of a substance, we could discuss the chemical properties of the substance. And substances, based on their chemical properties, will actually undergo a chemical change. An example here could be the chemical property of iron. Iron, when it's combined with water, H2O, and oxygen, will actually form a new substance, which we know as rust. So these chemical properties can define our substances. Now, physical, we just observe it without changing the substance. Chemical, though, would actually create a chemical change and get a new substance. Now, as we are looking at these substances, we are also going to use these properties to help classify matter. And science is all about classification. So we're going to classify things, whether they are physical or chemical, and we can actually classify them into even broader and bigger categories when we start looking at classifying this matter. Now, one thing that we can define matter as is a mixture. So if we just take two different substances, combine them together, and stir them up, shake them together, we have a mixture. These two substances are not chemically combined, so we could get back the original substances if we choose. And depending on how much of the two substances we mix together, they could have different consistencies. An example of this is sugar and water. If we add more sugar to the water, we'll have sugary water. If it's less, it would be less. Different consistencies. Now, mixture is one type of substance, but where we often want to look at is not a mixture, but a pure substance, something that always has the same properties. And when we have a pure substance, they have the same properties, and all of the particles are also the same. So everything in this substance is identical. Now, when we're categorizing a pure substance, we could look at our most basic pure substance, which we call an element. And the element is the simplest. It is just one kind of atom. And if we look at our periodic table of elements, we can see there's a whole bunch of them. A couple examples there: oxygen, silver. These are the purest substance, one element. Now, there are about 95 or so elements that occur naturally in nature. We can look on the periodic table. But when we start taking those elements and combining them together, we get a compound. And a compound is just two or more elements combined together in a different ratio, and they are not just mixed, they are chemically combined in some type of fixed ratio. So we need a certain number of elements to combine with a certain number of other elements, such as one that we are well aware of, water, H2O. That tells us there are 2 parts hydrogen and 1 part oxygen. That's how we get our H2O. Now, a way to easily remember this is by using this chart. All matter can be classified into one of two things: either a mixture or a pure substance. And again, remember, those mixtures are just combined together, stirred up. We're going to focus mostly on our pure substances. And pure substances are going to go one of two ways. They're either going to be elements, such as the periodic table, or compounds, a combination of elements. As we start combining our elements together, we are going to create chemical formulas. Now let's take our periodic table here, because from the periodic table we can start combining elements together to write formulas. But if we're trying to write the formula, the first thing we want to recognize is the formulas on the periodic table are either 1 or 2 letters, and they are often derived from the Latin name. Some of the elements' Latin names have actually translated into English, such as oxygen or carbon, but others, if we look down here, such as gold, AU, obviously that Latin name did not translate over. But the 2 letters, 1 or 2 letters, come from the Latin name. Now here's the important thing, standardization. When we are writing a chemical formula, the first letter is always capitalized and the second letter is always lowercase. And that's what we want to use. That's our convention for all chemical formulas. What we can actually do with the elements then, once we have their 1 or 2 letters, is we can combine the element symbols to make chemical formulas. And that's what we're going to spend a lot of our time looking at. Taking these elements, 2 or more, and combining them together to make formulas. What we also have to recognize is some of the elements on the periodic table will actually combine with themselves. And there are 7 elements that actually pair up as diatomic molecules. Diatomic meaning they combine with themselves. And those 7 are, as stated there, H2N2O2 F2 Cl2 Br2 and I2. Those 7 elements will combine with themselves to form a compound. Now we're going to talk more about why that is a little bit later, but an easy way to remember is look for the 7. These 7 form as diatomic molecules. They form a 7 on the periodic table, and then we can't forget about hydrogen over here. They form a 7 plus hydrogen. Now there are 2 other elements that combine in ratios that are not diatomic, not pairs, but larger numbers, and that's these 2 right here, P and S. P, when it combines with itself, comes in groups of 4, and S in groups of 8. And we're again going to look at that in more detail as we get further on in the course.